Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leader series and overview of BIM services for the design and delivery of building services. My name is Megan Purdy and I will be your host for today. Firstly, in keeping with our customs, Engineers Australia acknowledges the traditional owners of the land and recognises their continuing connection to land, waters and community. We pay our respects to their cultures and to elders past, present and emerging. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Hilti. Hilti engineers and technical specialists have lived at the forefront of construction. They've helped make job sites safer, more productive and more advanced. Hilti engineering solutions have set the standard for excellence, offering a range of technical solutions, services and software to help you to take control of your project from the initial design brief through conceptual detailing to final product selection and installation. Now, today we'll hear from two speakers, followed by our live audience Q&A, and I encourage you all to please send through your questions to our speakers via the YouTube chat box during our presentations. I'd now like to welcome our first speaker, Christina Watson. Christina is the Head of Engineering and member of the Executive Management Team for Hilti Australia. She has 12 years' experience in construction for Hilti across New Zealand, Singapore and Australia. Christina takes an enthusiastic approach to leadership and is passionate to make a difference for people and safety in the construction industry. She seeks to build successful partnerships to elevate the standards of design and installation, incorporating innovation within the construction industry. Please join me in welcoming Christina Watson.
Thank you, Megan, for the introduction, and thank you for having me here today. BIM's a really exciting topic, also a big buzzword in the construction industry. So I'm excited to give some more clarity, particularly to the services design. So if we look at the agenda that I'm going to run through today, I'd like to tell you a bit more about Hilti as a company. Perhaps some of you are already involved with our engineering team and we're supporting on a design side, but I'd also like to share with you what else we're doing as a company. And then secondly, I'd like to capitalize on what Martin would have spoke about challenges that we see in construction for services design or services execution. The third point I'll be going through is Hilti's BIM solutions, or what we have to offer in terms of a full solution for services. And the fourth point is a wee case study to showcase how you can realize the benefits of doing BIM design for your services. So let's talk about Hilti. So Hilti was founded in Liechtenstein, and it started in 1941 by two brothers. And it's still a family-owned company today, so it makes us very special. We're owned by the Hilti Trust. This safeguards the company, and it's privately held. We're in over 120 countries, and we're continuing to grow our employee base. Another exciting fact is that we invest a lot in R&D. So really look to how we can be market leaders in what we offer to customers, whether it's engineers or contractors on the job site. How can we innovate and make things more productive in construction? So we have over 60 new products annually, and we have over 2,000 active patents right now. One thing that we're really proud of is Hilti is what we are putting back into society. So there's three pillars to our sustainability approach. One, be it environment, the second, people, and then the third, society. So we do a lot of activities globally around these three pillars. And why I mention this as a sustainability topic is what we're talking about today on BIM and services design. It really ties into people through health and safety and building safety. So what we're doing as engineers or construction workers, we really have a part to play on health and safety of our people, and also building safety, which is going to safeguard society, which is the third pillar. Our direct customer approach is also what makes us unique. It also means our people are specialized. We're on the job site every day. We have over 250,000 contacts per day. Some of you might have met our engineering team. We have a national engineering team, approximately 35 members. We also have over 150 account managers, which is our sales team. So we're really close to the customer, and this gives us a lot of insight, and we see a lot of the practicality of design and execution. Hilti is famous maybe for our fasteners and our tools, but we're really working across the whole workflow of design and construction. And when it comes to engineering, it's not just the consulting and specification assistance that we give. We're continuing to expand our software offerings, and we also now offer the BIM modeling service as well. Our measuring, drilling, cutting, grinding, fastening is really all the products and services that we offer in the build phase of a construction project. And then through the operating stage or the validation phase, we have a number of documentation software or services that help to tie everything back and realize and secure what was initially planned in the design. I hope that gave you an overview of who Hilti is as a company, how the engineering and BIM topic ties into sustainability, and what we can offer. So we see challenges in construction, and you heard from Martin. He would have spoken about the codes and approvals challenges, how they don't talk to each other. All the different trade codes are separated. So I'm just going to also speak about some of the challenges in a summarized way. So we see several focus topics and trends in the construction industry. And some of you may be aware that there's reports coming out from the likes of McKinsey that look at the construction industry being so far behind industries like production because we're not incorporating innovation, technology, and as a result become less productive. So this is one key area. Also, post-COVID world, we all know the challenges around getting skilled employees. It's hard to recruit, it's hard to retain, it's an attractive market if you're willing to step up a job, and this puts pressure in construction as well. We've seen the steel prices shoot up. This puts pressure on material costs, not only for suppliers like us, but for the contractors on the job site, that not only the cost, but the availability of materials at high volumes is a big challenge. And then the third topic is digitalization. So making everything more efficient, whether it's through data management or services like BIM. So I would highlight these three areas as maybe what we see the most, and also where BIM plays a role. Early investment to utilizing something like BIM will be realized in terms of cost and time later on. If you see the graph, the costs can really shoot up towards the end of the project because there's a lot of immediate works, there becomes clashes. These kinds of things can blow the costs out. So if you're able to utilize BIM up front, you're able to reduce a lot of these issues, which therefore will impact the cost and the time of the project. It also reduces the level of complexity and allows one source of truth for all the trades to work around. So our traditional method and how we design services is tag all the separate elements out, whether it's plumbing, HVAC, electrical, everything's tagged out and everyone designs it individually. And then on the job site, they're trying to collaborate and redo things. So whereas if you have a BIM model, you have one source of truth that everybody works around, and you're able to reduce a lot of that complexity, the clashes, and you give one place for everybody to go back to. So now we've looked at the challenges and what we're really talking about in the construction industry, what we're trying to solve with BIM solutions. So what do BIM solutions look like from a partner like Hilti to really offer an end-to-end solution. So if we look at what's in scope in terms of applications, it's about the piping trade, HVAC, electrical and IT, and then also relevant for the civil. And this is seen through these 4 key applications. So the modular supports themselves, the fasteners, the fire protection, ceiling products, and the cable transit. So these would be the product types that we're talking about when it comes to the services. So what we offer at Hilti is really an end-to-end to try and incorporate things using the digitalization of BIM and the services that we have through our software, along with the products, to be able to offer you a full solution across the workflow. So when it comes to how BIM plays a part across the workflow, early on, it's about design, optimization, and the modeling. And this takes you through then to be able to prefabricate your models early before going to the job site. So if you're able to standardize the design, you can have everything prefabricated, ready to go, and you can then take it to the next level using a just-in-time style model to make sure that all your materials are going to turn up on the job site at the right stages of construction to execute in the fastest way possible. Then it's about utilizing the model of BIM to field, and this is really in regards to drilling your anchor holes. So there's a couple of products that we have on the market now, which I'll speak about soon, and the exciting robotics drilling, which is really cool, and that video I will show you shortly as well. The last part around finishing the build phase and operation is about validating the model using something like a total station and being able to report back and verify through documentation that the model is, in fact, what it was designed out to be. So as engineers, structural engineers, that you may be already using some sort of BIM modeling to reduce the construction time of the building envelope or the main structure. It also applies the same when it comes to the services, where we're able to realize up to 10% duration of the full project. And so this would mean a lot to the client if they're able to reduce the time by 10%. And time equals money, time equals people. This is a nice benefit if you're able to utilize them for the services. At Hilti, we break it up into 6 dimensions, and I will go maybe only into a few in detail. If you're able to do the design optimization and then also put it into the model, this gives you the best opportunity of savings to be realized across the next steps. Prefabrication would then allow you to have advanced logistics, things like labeling and a just-in-time model. The BIM to field allows you to realize the execution savings or the productivity of the installation, and then the validation in the field to BIM additionally as well. So I will talk about design optimization next and what this looks like. So if we look at design optimization as a comparison, the left-hand side is perhaps the traditional way that services may get designed. So they're all done separately. The clashes aren't able to be identified up front. They're all in different support systems that's going to add additional fasteners, and the solution isn't sometimes defined on the experience, or it's improvised on the job site like a design and build contract. If you're able to design up front, you get to optimize the space. You can include not only the mechanical and electrical applications, but also the fire protection. And the savings can be significant, from the material costs up to 60%, installation time up to 50%. The work health and safety improvements by reducing the exposure to things like dust, the shoulder fatigue that the construction workers will get trying to drill holes overhead, and then obviously reducing a carbon footprint by reducing materials and time on site of construction. This is an example of the fire protection, which quite often is left to the last part of a construction project, and they also are trying to avoid clashes. If the BIM model is done early up front with the services, additionally, the fire protection can also get added as a detail. And this has the same benefits that I've already spoken about earlier. So what it looks like when you utilize the service and you get someone to do the design optimization with the inputs that we get from the basic design and all the different supports that would be in scope, we're able to then follow through to do the design calculations, work out what would be the most optimal way, reduce materials, optimize the supports, and this is what it would look like that would come back. So it comes through a formatted engineering report. It includes all the details, the relevant approval documents, the seismic testing, etc., etc. Additionally to these reports would be the drawings and the bill of materials. So the material takeoff is really helpful to have upfront, particularly in this environment where we see a lot of stock challenges on large projects, particularly that are going to be purchasing at large volumes. So further to doing design optimization is being able to then put it into the BIM model itself and translating this into the 3D model to then be utilized by all trades. And this is the next level of the design optimization that we offer at Hilti as well. So next I will talk about prefabrication, really what the productivity savings are there. So this is one service that we also offer to the market, is doing prefabrication. So by utilizing BIM, being able to standardize the supports. So for similar types of applications, we're able to reuse the same support across the board. This makes it quite easy to assemble and fabricate early and have everything pre-assembled and kitted. So this is a service that we offer, and it's really going to help productivity on the job site when it comes to installation. So prefabrication services include pre-assembly, the kitting, and then also the cutting. So cutting where it's needed, taking large pieces down to short pieces, and having everything done before the job site starts. So this will really help you save as a client, as a main contractor on the job site, as a service that we offer. The next dimension that I want to talk about is BIM to field, and this is if you take the services through to the 3D model, you're able to input this into things like a total station or a JBot, an automated drilling robot. So taking this model, as a minimum, you can use something like a total station, making sure that the workers that will be drilling the holes are going to be accurate in terms of where they place it. And this is about avoiding the clashes and having it as per what the design was intended and follow through in the model. The most exciting one is the automated drilling robot, the JBot. And so this avoids people altogether as it drills the hole itself. And so this is the safest way to drill in terms of reducing the dust exposure to our people, the fatigue of drilling overhead, not only the cost of the manpower to do it and the cost of equipment. So this is a really exciting product, and there's 2 now in the market in Australia. So next, we will play a short video to kind of show you how the JBot works and how it can be incorporated with the use of BIM for services.
At Hilti, we strive for change. Around the world, our innovations have shaped how work is done on today's job sites. Today, our ambition remains as strong as ever, to drive productivity through innovation. With BIM, we've already entered the age of digital planning. What if we could use the same data to not only streamline processes, but simplify trade collaboration and automate repetitive and strenuous tasks? Now our vision becomes reality. Introducing the Hilti J-Bot, a semi-autonomous drilling robot for ceiling installations, helping you to deliver MEP projects on time. Let's not wait for the future to come. Let's shape it together.
I hope you enjoyed that short video about our J-Bot. If that's really exciting for you and you really enjoy the technology of that, definitely search more on YouTube, read more about it. I think this is going to be a game changer in the market of construction. As the years go by, we'll see more and more of these things incorporated into the job site. So a bit of overview of the specs of the J-Bot. So it can drill at ceiling heights from 2.6 meters to 5, requires plain concrete ceiling and floor access, obviously. The drilling accuracy is down to plus or minus 5 mil, and the drilling depth accuracy is plus or minus quarter inch. So it's really accurate. And this is kind of how you can incorporate everything from 3D design and modeling through to job site execution, and allows you to do absolutely everything, and also in an automized way. And the last part is you can also then get the reporting validating back exactly where holes were drilled, were there any issues, did you hit any rebar, etc., etc. So this is a really exciting product that we now have in the market in Australia. So the last piece is I just want to take you through an example that will help iterate why would you want BIM, or as engineers, why would you recommend this to a client or a main contractor? So not only utilizing BIM for the structure, realizing it through to the services for a client or a main contractor is really going to help them on all of the challenges that we hear that they have all the time. So the case study I have is on a data center. The data center example I have, I'm not able to disclose where and what the project is, but I still wanted to share it regardless, even though I can't name it, because I think it gives the best example of where the savings can be realized. So the end-to-end construction time was approximately 10%. The installation time was 70%. The materials savings was 40%. And the space utilization was reduced by 50%. So not only those elements, it's also linked back to health and safety and the impact on sustainability by reducing all of these things down. And so this is how it's realized. A traditional split is maybe how we see most designs today. Everything's done separately. Each subcontractor is designing it in their own way off a basic amount of information, and it utilizes the most space and the most materials. And in this case, by using a multidiscipline support and using the design optimization, the space was reduced by 50%. And the next slide, I'm going to take you through how many supports and anchors were reduced, as well as the cost. So the number of supports really reduced down by the end by 77%. So it went from all separated trades using 1,200 plus fixings down to 408 fixings. The support costs themselves went down to 50,000 Swiss francs is the example here, which is approximately 40% cost savings. The installation time, which translates, of course, to money as well, went from 245 hours to 65 hours. So the savings really are significant on projects in energy, IT, big data centers, where the services are high volumes. The realization of savings is going to be even more significant. But the opportunities are still there in the commercial projects or the likes of hospitals, which also have the same high volume of services. that a data center would have, we also have the same opportunities in Australia to execute projects utilizing this kind of technology and available. And that is my last slide to kind of summarize what we have as an opportunity in Australia to change the services game. And just to summarize the benefits, it's really about the upfront problem detection, around also compliance, having things designed upfront. You're able to ensure that things are designed properly. You're able to make sure the clashes are avoided. There's a simple project management and coordination that comes from using a BIM services model. There's shorter and safer on-site construction, and the opportunities are endless. Using things like the JBot is really the ultimate level that you can do this at. And lastly is improved coordination and cost savings. So for a client that really cares about sustainability, optimizing the whole project, this is really the direction they can take it. So if you're more interested in BIM services or even the JBot, we have a full team at Hilti in engineering and sales, and we're there to support and partner from either the design stage or also any references through to the client or the main contractors that want to incorporate this. Please reach out to us and we'd love to talk. We're really passionate about what we do at Hilti, not only from design, but things like the automated drilling robot. So thanks for having me today, and look forward to probably meeting some of you out there as well. Thank you.
Thank you, Christina, for your insights. I would now like to welcome our second and final speaker, Martin Cuz. Martin is a chartered structural engineer specialising in the seismic design of building services. His design perspective is influenced by a background in mechanical engineering and construction project management, enabling him to communicate effectively with all project stakeholders. Martin runs an engineering consultancy firm dedicated to the design of non-structural building elements for seismic forces. In rare events with extreme consequences, Martin's mission is maximum seismic resilience for minimum overall cost. Please join me in welcoming Martin Cuz.
Okay, thanks for that introduction, Megan. Hi, my name is Martin and I run a structural firm that's heavily involved in the design of structural support framing and systems associated with non-structural things or building services. We have worked with Hilti for a long time. Hilti products are frequently being used in our designs, and there's new Hilti materials and systems that are becoming available, which are quite exciting because they're going to be able to solve a number of complex problems in this particular space of non-structural structural design, or the structural design of the support systems for building services. So let's get underway. Now, structural engineering for non-structural things sounds a little bit crazy, and well, it, in some ways is. Here's a photo of people standing under some non-structural things, in this case, mechanical pipework. Now, it's a very common sight on any large structural construction project anywhere in the country. But there's a number of structural things that are taking place in this picture. There's some loads, and at the time of the photo was taken, these loads were being successfully resisted. There are load paths with capacities, and in this case, those capacities exceed the demands. Now, how was this achieved, and what was the typical design flow that led up to this particular point? Well, typically the design of these large, complex construction projects begins with a design team made up of specialist consultants with various expertise. Each consultant produces a design of a particular facet of the project, and often projects have a lead designer, commonly an architect or perhaps an engineering consultant that provides overarching direction and oversees the coordination of each design element. Now, the mechanical consultant designs a mechanical system and produces design drawings and a design specification. Now, the mechanical design doesn't detail the supports of the pipework, ductwork, or equipment, but likely provide some typical details and will specify some standards that the structural support of pipework will need to comply with. Then there's a tender process. The design drawings and specifications end up with a head contractor who engages subcontractors. The mechanical subcontractor takes the consultant's design, he value engineers it, he produces their own fabrication drawings, and they work out how to support and anchor the mechanical system. Now, this fabrication design may or may not be submitted back to the design consultant for review, but ultimately the mechanical contractor builds a system that is reflective of the mechanical consultant's key objectives and is hopefully in accordance with the NCC and the design specification and the relevant design standards. So back to our picture demonstrating some loads associated with some non-structural things. The design of the support systems that resist these loads is typically completed by the relevant contractor during construction in accordance with a design specification and some relevant standards. In the case of this large pipework, there's a few things that are working in everybody's favour here. So the mechanical contractors usually have a number of mechanical engineers on their team who, in addition to understanding fluid and thermodynamics, they also have a good knowledge of the mechanics of materials. They're trained to assess structural forces, the stresses and the displacements that forces cause, and to design materials to resist those forces. So there's generally a relatively strong overlap between mechanical and structural engineering disciplines, which is somewhat evident in the standard that is actually applicable here, which is AS4041, the design standard for pressure piping. Now, this standard lists out various design loads that are to be considered in the design of the support system that is holding those pipes there in that position, which evidently are suspended over people's heads. Now, the standard AS4041 goes so far as to reference two other structural loading codes, the wind load AS1170.2 and the seismic code AS1170.4. And that's pretty special because it is perhaps the only building services standard that does reference structural loading codes. The design of support systems for hydraulic pipework, ductwork, electrical systems, or fire sprinkler pipe is all completed by the contractor in the construction phase of a project, same as with mechanical pressure piping. But none of these particular standards contain any reference whatsoever to the structural loading codes. Now, an obvious question is, well, do they need to be? It's got to be pretty simple. Aren't there some tables or something in each standard that, well, deals with this? Well, yes, to an extent. There is guidance on recommended support spacings in each of these standards. The size of threaded rod and, say, trapeze members is also probably included in many situations. And contractors know these standards very, very well. And it's a good reason why it's quite rare for suspended services to become detached and to fall on people. But there have been a few developments within what we might consider structural design standards that have mandatory implications for the support of building services. And yet the standards that the contractors rely on to carry out this design do not direct them to the relevant information. Now, here's a quick diagram highlighting the references between standards associated with the support of building services. The NCC references the structural loading standards as well as the steel, concrete, masonry structural design standards within the section of the NCC that applies to the structural elements of the building. The NCC also calls up a relatively new standard, AS5216, which is there for the design of concrete anchors. And of course, the NCC references the plumbing standard, the duct standard, the electrical standard, and sprinkler standards. Now, the structural loading standards contain clear provisions that determine the design loads that the support of building services need to consider. And the structural materials standards and anchor standards are all able and they're all available to guide the appropriate design of support systems. But there's no reference between the plumbing, duct, elect, and fire standard that will point contractors who are familiar with these standards to the structural loading codes or to the structural materials standards in most cases. And yet, the ABCB and every state regulatory body has issued statements over the last several years confirming that the loading requirements within AS 1170.4 apply to the design of building services. And every construction contract contains a clause stating that construction must be in accordance with all aspects of the NCC. So what we have throughout Australia is plumbers, electricians who know their standards very well, but they're being held contractually liable for understanding and complying with structural design load standards because they form part of the NCC. And this is despite the fact that those design load standards are not referenced in the building services codes. And in many cases, they may not even be referenced in the design specifications that are prepared by engineering consultants. And there's pretty big implications with that. I had a call from a contractor who had just finished construction on an auditorium when the building certifier informed everyone that they needed to submit a seismic design certificate for their work. Everyone had received a list of certificates that they needed to provide at the start of the project, and seismic was not there. The certifier evidently was made aware of this particular relatively convoluted link between the NCC, the structural loading codes, and how that applies and impacts the support of non-structural services. But in the end, the overarching clause of needing to comply with all elements of the NCC was invoked, and despite the fact that ceilings had been completed throughout this particular project, the building services contractors were required to undertake additional design and complete additional installation at their own cost. Now, is this reasonable? Is it reasonable to hold plumbers and electricians liable for understanding, designing, and constructing the structural design, load, and material standards that they have no training in, when the standards that they are trained in have no, or even in some cases, contradictory guidance towards such requirements? This is an example of a simple problem with the support of services, but it has very, very big compliance risks, as well as very big performance risks and very big contractual risks for everybody involved. Now, the design team and the building contractors were all unfamiliar with the requirements for services to be restrained in a way that is going to resist rare earthquake events. They reached completion only to find out that there were key National Construction Code requirements that had been missed. And this is not in any way an isolated case. This is unfortunately very common. But the issues that are associated with the structural support and performance of non-structural building elements can actually become significantly more complicated than just failing to install seismic bracing. Let's consider some of the complexities associated with the design of structural supports for building services as we consider what current construction methodologies require contractors to understand and consider in their design of support systems for services. Under the NCC and the referenced structural loading code, services contractors are required to design their systems to support and the support of their systems in a way that accommodates building movements. It includes interstory drift due to wind and seismic loads. It includes slab deflections and the core shortening of concrete structures in particularly high-rise towers. Here's a few examples of where the design of non-structural elements is significantly impacted by building movements. Well, there's vertical pipe, duct and electrical services rises in tall buildings, and core shortening of these structures occurs, but how do services accommodate this movement? Now, an inspection of a services riser in a high-rise building will often reveal plastically deformed steel framing and brackets. Now, steel standards provide provisions for designing steel beyond its yield strength, but it seems highly unlikely that contractors are employing plastic design principles. It's far more likely that the load distributions due to construction sequences and the natural shortening of concrete structures over time simply isn't understood or accounted for. And the ductility of the steel framing that is there just happens to be working in everyone's favour. Now, interstory drift is another key movement-related issue that impacts the design of the support systems for non-structural building services. Now, facade engineers consider and accommodate structural movements as a key design component of their element. But this is rarely considered with the design of internal non-structural elements or services, and with unfortunate consequences. Many of us would be aware of squeaky wall syndrome in high-rise residential towers, which is simply a function of stiff plasterboard walls being forced to elongate in plane under interstory drift effects. There's escalators where we have a very, very rigid structural system, mechanical system with very rigid structural properties that is supported on two separate slabs, linking them together, and the interstory drift of the building structure is bridged by this, non-structural element. Problems can also arise with stiff mechanical pipework in a plant room where you might have say a large chiller, very large 350mm diameter pipe that connects rigidly to a chiller on one floor and is supported and rigidly connected to the floor overhead. And interstory drift is going to create sometimes fairly significant forces in that whole system. Are they being considered? It's quite unlikely in many cases. There's the deflection of slabs. Structural slabs obviously are suspended. We design them to deflection limits, but frequently when contractors get involved, they throw in partition walls. They may be directly connected. Sometimes there's a deflection head track. Sometimes that simply is, the amount of movement is never enough. You end up with bowing walls, and maybe that's not a big deal until perhaps we're trying to confirm that a fire-rated partition wall will continue to perform as it's tested under some structural load. Another big issue that we have in this whole space of the structural support of non-structural elements has to do with the use of post-installed concrete anchors. Well, most non-structural services or elements connect to the building structure using post-installed concrete anchors. There's very clear requirements about the development of concrete anchors and the rating of those concrete anchors and the use of those anchors. They're all mandatory under the NCC, but they're not referenced in the services code. So plumbers and electricians really going to understand how to decipher that. Are they going to even know to look when they're coming to a particular, coming to install their particular elements? There's also significant spatial constraints. So it's very, very common for consultants to compress all of the services into a services corridor. But the contractors that are going to be responsible for supporting all of that and then have to allow for horizontal seismic loads, it might not even be physically possible to put structural systems in place to restrain that. So what happens? Well, likely it kind of just, people turn a blind eye, it gets forgotten about. We aren't actually designing in many situations, we aren't providing the appropriate performance that the NCC mandates, just because by the time that problem becomes the contractor's problem, they don't have options, and they do what the best they can, I guess. I've also mentioned firewalls a few times. Now, services and firewalls frequently will interact. There's penetration. Services penetrate through firewalls. Should fire separation remain serviceable after an earthquake? After an earthquake, there is definitely a significantly increased risk in fires, but the the standards that we have don't actually provide clarity or guidance on these sorts of things. So we may be expecting certain levels of performance, but when you start to chase these problems down the line all the way through to construction, there's different gaps in the whole system that we have here that mean that end result's quite unlikely to achieve the performance that we're hoping for. And on top of all of that, there is the competing pressures of robustness and sustainability. Do we just improve the structural performance of all of these non-structural things by throwing more material at them? Well, how can we improve robustness while reducing the amount of material required? So a few questions. What can structural engineers do to help here? Well, we can ensure that the building services consultants on our design team understand the structural requirements. We have design team meetings. It's very easy to just provide clarifying direction to the other consultants. Make sure you consider X, Y, Z in your specification. You should also help the design team understand the implications of a number of these structural implications. You could also help by providing realistic interstory drift requirements. Everybody else down the line has to design and accommodate for that. 1.5% interstory drift is actually very unrealistic, and it's very, very difficult to actually achieve with non-structural elements. You could also help with the provision of floor accelerations and potentially even considering specialist consultants on the design team if you feel that there's a gap that isn't being appropriately filled. It's important just to consider what our responsibility as structural engineers on projects. Section 3.3 of the Code of Ethics says that we need to make reasonable efforts to communicate honestly and effectively to all stakeholders, taking into account the reliance of others on engineering expertise. Well, the entire design team relies on the structural consultant for these sorts of things. And yes, we've pushed the design of the structural design of the support system for non-structural things down the line, but we're the experts. The structural consultants are the experts in the room. Now, it doesn't mean you need to be involved in designing those support systems, but you have an obligation to the project team, to the services consultants and the contractors, to provide them with the direction or the guidance to make sure that down the line, the structural performance of the tower that you've designed is well understood and it's able to be accounted for. Now, what can services engineers do also to help in this situation? Well, make sure that you understand the structural objectives and make sure that you're able to provide clear direction in your design specifications and details. If you're unsure, then get clarification from the structural consultant. If they won't help, we can help. Call us. You need to consider the horizontal design load requirements when proposing services paths. consider if you're going to compress all services down a particular services corridor. Well, that whole system has to be able to resist a horizontal load. You need structure to be able to do that. Has that been allowed for? If it's not, it's unlikely that the contractors down the line are going to be able to build that to the required structural loading codes. Now, do what you can to provide clear details in your specifications, and if you need to obtain specialist assistance, well, that is available. One other question: can contractors reasonably design support structures themselves? Well, if they can't, design specifications should be very clear about the need for a contractor to engage a structural engineer or another appropriately qualified engineer that can design and certify these systems. Now, what could the ABCB or the standards committees do to help improve the actual design process here? Now, if anyone happens to be on one of the services standards committees, the structural design requirements that are being imposed on contractors must be clearly referenced in the NCC and the standards that these contractors use. It's unreasonable to expect electricians to just know about developments in the structural loading standards or the concrete anchor standard. Now, for many scenarios, simple deemed to satisfy solutions can easily be updated such that contractors don't need to engage a structural engineer. It's not necessary for supporting PVC drainage pipework in a building, but we need to make sure that the standards they're working to are aligned with the other structural standards that the NCC requires that they comply with. Now, I know also that the ABCB issued a statement a few years back clarifying the need for seismic loads to be considered in the design of non-structural elements. That was helpful, but please, there needs to be clear references in the NCC so that everyone in future is aware of what the National Construction Code requires of them when it comes to the structural performance of the support systems for non-structural elements and building services. Now, I've provided this background because improved compliance with the structural design requirements for building services starts with clear direction from engineering consultants. But what else can be done? Well, building information modelling has progressed to the point where the structural support of building services can be modelled in detail. And if it can be modelled, it can also readily be analysed and engineered and certified. And if we start modelling and designing support structures for services, we can also begin to achieve improved efficiencies in the use of material and the required labour to construct these things. And this is a space that Hilti have been advancing in Europe and the US and are now making available to construction projects in Australia. Thanks.
Thank you, Martin. Our speakers will now come together to answer your questions. So if you would like to submit a question, please do so via the chat box. Big thank you to everyone who have already submitted a question. I can see the chat box has been going crazy. So what we might do is just quickly jump into some of those. And the first question that I have is from Dallas. So thank you, Dallas. And his question is, Christina, we might kick off with you. We'll give Martin a bit of a break. And his question is, how does design optimization work when major services are not all under the same contract? Is there an open source BIM model option where multiple external collaborators can contribute their design?
Yes, thank you for the question. I think there was also a similar question later on how can we incorporate the expectations of having a structural designer involved in the services. But essentially, you've highlighted the issue that we have. In order to execute BIM, you really need to have the client or the main contractor having the ambition and the want to include BIM on the services. And therefore, the contracts that would be designed would be incorporating BIM for the relevant services. Ideally, it would be one person executing it, or you can even get away from all the trades being separated out, because if you've done one model or one support system. All that needs to be done is the fixing holes and the installation. So you don't have all the complexity of doing one plumbing contract, one electrical contract, etc., etc. It becomes just about the installation. But the codes and approvals complexity is also a barrier, which Martin went through. But it's really about that upfront decision, either from the client, the main contractor, to have that vision for the project, to be able to change the way that we design the contracts for services. Maybe Martin, would you like to add to that a bit more? That's probably the
Yeah.
biggest challenge.
I think that's definitely the case, that current procurement processes and methodologies have, are pushing all of the design on of a fairly significant element of the construction project onto trades, and they're working in independent silos and trying to get everything done independently. Now, there are a couple of reasons why that currently is very, very common. One would be that there's a value engineering phase that happens after tender. But I guess pushing that design element down into construction phase, you're never going to be it's more difficult to collaborate. So definitely a decision up front to get a to incorporate a coordinated BIM solution needs to sort of take place at front to get the full benefit of it. Now, we've had some experience where we would get involved with a head contractor during construction, and we may provide an overarching design service to try to pull all trades together into one overarching structural certificate for all services. And we, in that situation, I believe that provisional sums were put into contracts for I guess the design of the seismic support systems, where we would then get novated across, or every trade would need to then come and work to us. And that enabled us to create those sort of multi-service support systems down congested corridors and those sorts of things. Now, another thing that we have also done in the past would be to just work with a couple of contractors that are able to collaborate. They've got a good working relationship, a mechanical and electrical contractor, and they might decide, this is actually going to be cheaper for us to combine our supports, or the support of our services. One trade might go in first, and it's typical for the electrical trade to come in underneath, and we are able, where two contractors are just happy to collaborate, we're able to develop those sorts of systems kind of in isolation. But I guess the real goal would be to get that design right up at the design phase, so you can start to really achieve the reticulation of services can start to be at the tender phase, can be already well underway in design. We're putting the heavy services close to the slab where they perform best under seismic loads, that sort of thing. So
yeah, maybe one more thing to add there, yeah, it is a good question, is on larger projects like hospital projects, for example, we have seen that maybe the specialist in plumbing or the specialist in one of the trades is trying to achieve BIM modeling and optimize. And this is fantastic and it is doable, but you don't get, of course, the scale because you haven't got all the services combined into one. You've got one isolated trade that wants to make improvements. So the improvements are really only to a certain level, because really the harmonization of all the trades to realize that benefit is what's going to make a big difference. But it is still doable in the traditional contract model, but maybe not so beneficial.
But like that chart, Christina, that you had, where the benefit, the cost benefit ratio, the further down the line you push the BIM design, the more expensive it is and the less gain you get from that. Bringing the design up to the design development phase, engaging the design, a designer or a specialist of support services designs like Hilti at the design phase in the design team alongside the mechanical, electrical, hydraulic consultants and the structural engineer, the potential is there for you to resolve all of those problems with a support solution, or at least a proposed support solution. And everybody can see, okay, down this services corridor in my hospital, we've got a multi-services trapeze support corridor. And it's very easy then to pull that element out of all of the trades contracts. They're not responsible for providing the supports down that services corridor because we've got a coordinated multi-service system going in. So,
yeah, exactly.
I might jump in with a question. It came through from JT, and I am assuming the answer is no, but his question is, may I ask if any BIM standard, is there any BIM standard in Australia for the construction industry?
This is a good question. From what I've understood, there's specifically not BIM added into any of the standards, especially the trade ones. Where I've seen it work quite well in Singapore is the government includes it in the codes. So you see an openness from main contractors to try and incorporate it into their workflows. I think the other country that does have it in the legislation is the UK. But from what I know, maybe Martin, you can comment, but specifically, I don't believe there's any BIM integrated into any of our codes or standards.
Not that I'm aware of, no. I can't. BIM's certainly not integrated into any design standards, particularly or especially if we're talking about building services. It's cutting edge developments, really. It's emerging technology, so I guess this space is sort of ahead of the, ahead of the codes. It'll take a while for codes to catch up.
Yeah,
excellent.
Exactly.
Thank you both. Now I've got a question, another one from Dallas. Dallas has been busy in the chat box. For raw materials, is the JIT model for materials still considered best approach, considering extended material delays in the post-COVID world?
It's a really good question, but I think it's also just situational and what kind of scale are you talking, what kind of project it is. In the context of utilizing BIM for the services, and we see this in Hilti, our biggest users of BIM and installation systems are offshore and power. And then this is where we see just in time being really critical. Also, the project, if they're invested to do the prefabrication and standardize the supports, then a just-in-time model would probably be quite feasible. I guess at a smaller scale, to your point about availability, if you were talking to maybe one of the subcontractors on a construction project, they probably would find it challenging to implement a just-in-time model for exactly the reasons that you mentioned. It really depends on the product that's going to be involved in the system and to what level you want to achieve just in time. If it's something like a standardized support, I think you can still achieve it for sure, because you would have done BIM upfront early on in the design. You'll have your bill of materials and you'll be able to engage with suppliers early on to build in a just-in-time model. But if you're a subcontractor on the job site and you get a tender, you've got 2 months to try and put something together, then a just-in-time model probably isn't going to be feasible for you to be able to execute. That would be my thoughts on that question.
Excellent. Martin, did you want to add anything there, or all good?
I would agree. I think, when we're designing during construction, like it's get it up as fast as you possibly can. You don't have the time to schedule. If the design is happening up front, it's very easy to have that procured up front months in advance, and it's scheduled. Deliveries are scheduled, and it turns up on time. Obviously, scheduling in construction projects, as most people probably know, is a pretty messy space anyway. There's always delays and schedules are frequently being updated. But with the no, like I think if you're designing during construction and you're just trying to get it up there as fast as you possibly can, you probably want to have stockpiles of material, particularly at a time when availabilities are not certain. So.
Thanks, Martin. Okay, I have a question from Karthik. And Christina, this one will be specifically for you. Can JBot be used in all environments, not just in buildings?
I think essentially, yes. We have had the JBot used in other countries in tunnel projects. As long as it's concrete and it's for drilling anchor holes, which is the purpose of the JBot, then any environment can work. I think with tunnels, it's also challenging then on the ground level. But essentially, the answer is yes. It would just be working through the details of is it concrete? Is it going to fit? Is the ground surface going to be smooth for the JBot to drive across? But not just buildings would be in scope for the JBot.
Excellent, thank you. I've got a question from John Duve, and his question is, have you any examples of how the contractual impediments to using an integrated services model were overcome? And then does the Hilti design service include seismic aspects?
Yes, so I think our first question kind of touched on the challenges on the contractual elements of subbing everything out. Maybe Martin can help me with some examples, but essentially the second part of the question, does Hilti's design optimization include seismic? Yes, we make sure that the team's educated on the Australian codes and standards and our local team here as well. And everyone would be able to design to the seismic standards for Australia and have it in scope for that service. So to answer the question, yes, the second part.
Probably an additional and essential part of that is that Hilti's design service, it comes with independent third-party structural certification. So there's a structural engineer that is overseeing what's produced and is directing the consideration of all of the structural implications that I covered off in my presentation: interstory drift, core shortening, cracked concrete conditions of and the design of fixings, and seismic design is one as well as wind and the full suite of structural design load considerations that the NCC specifies. So,
yeah, I think also just to answer the first part of the question, what kind of challenges come up and how will they overcome? From my learnings and hearing from our Hilti team that have been involved in BIM projects for the services, the biggest challenges are the clashes. And so if there's not a complete design up front and changes happen quite often on the fly as the job's happening, then this is where the communication comes into play. Are there frequent meetings across teams that are doing the different installation? And is everybody actually using the 3D model, or are people off going their own thing? So I think the challenges come around people and process management actually executing on the job site. So I guess the ways to overcome that is making sure that's set up in place from the start. And that probably also comes with experience doing BIM services and executing on a job site. If you're a main contractor and you've done it once, you would have learned all the potholes on setting up these good practices for communication across teams that are doing the installation and using the model, essentially.
Thanks, Christina.
Christina, I think there's a few... Sorry, can I add
keep going?
Yeah, you should
Yeah,
add.
so there are a few developments that I'm observing in in the construction industry. So, for the last decade, there seems to be an approach where, BIM is getting increasingly common, but teams have still been working in isolation, and everybody will sort of like on a periodic basis, 1 week, 2 weeks, or something like that, they will then federate all of their designs into a federated Navis model. They'll have this whole clash detection where you go through a federated Navis model, you try to identify, and then you go back to work on your separate BIM model. But what we seem to be seeing now through the likes of additional developments in the BIM space, things like BIM 360 or Procore, which seem to be increasing the real-time collaboration between all of the different parties that are developing this model. So where once upon a time you had this very sort of still a relatively isolated design process, well, now people can be working almost, we're getting closer and closer to being able to have multiple different teams working in a live model, so that when you put a pipe in a particular location, well, you see where everybody else is, and perhaps they're working. And so there's just real-time collaboration and adjustment to, deal with things like clashes. So I think that what we're going to see moving forward is just improved ability for design teams to collaborate and get these things right, even after tender, even during the construction phase. So I think options will increase.
Thank you both. Martin, I do have a question which has come through from Pierre, and it's specifically for yourself with, I think you raised it in your presentation. The question is, hi Martin, can you cite a specific example of different building standards providing contradictory guidance to each other? It's interesting that you mentioned this generally in your presentation.
Yeah, okay. Well, I mean, the first one would be that all of the services trades, the electrical, ductwork, hydraulic, and fire trade, they provide contractors direction on how to support things, but don't tell them how to provide seismic support. So if you picked up that standard, you would think that, okay, if I need to hang a pipe, this is how I do it. And that's precisely what is happening. Now you have a separate standard that is telling you, no, you can't just hang it like that. You need to add seismic restraint. So that would be one high level, one overarching, I guess, issue that we have. Now, another that you would have in the the fire sprinkler pipe standard, it tells you what type of anchors. It tells you how to calculate design loads for those anchors, which is completely separate to the way AS5216 tells you to calculate anchors. And the sprinkler pipe code tells you nothing at all about considering cracked concrete. And here the concrete anchor code provides very detailed requirements about the rating of anchors and how you design for those. So there are other standards where it would, if you read them, they would imply that seismic design isn't necessary in some regions, and that's not what 1170.4 says. Seismic requirements apply to all construction projects except for importance class 1 buildings, which is farm sheds, and small residential dwellings, which houses essentially. Everything else has to be designed for seismic loads. Now, the standard does give different provisions. So an EDC1 project, there's a very simple way of calculating seismic load. EDC2 projects, as the project grows in complexity, the level of detail you have to go through might increase, and the amount of simplification sort of would reduce. But I guess the contradiction there would be that there are some services standards that would imply or infer that if you don't think that an earthquake is likely, then you don't need to design for it, whereas 1170.4 doesn't agree. So.
Thanks, Martin. We had a question, this slight change of tact. It came in from Aaron, and his question was, how can the education institution play a part in the movement towards BIM implementation? So I might hand that over to, I don't know, Christina, did you want to kick off, and then I'll throw to you, Martin?
Yeah, I think it's a really great point, and you highlight something. Obviously, education, and then we've also explored already that there's a lack of, I guess, codes and approvals and standards as well as guidance. There's probably also no practice codes as well. So there's a gap not only there, but I think education and universities would also be really fantastic. So our new graduates at least have a skill set to be able to change the way that we do construction with this knowledge, or be more open as well when they leave. So I think I really liked your question and almost highlighting a great opportunity. I think we can also follow up. Part of your question was what organizations and consultancies can support here. And I think we can maybe connect after the webinar.
I'll probably add to that. I think a key thing from thinking about, say, TAFE, and you're bringing people through with education, you really need to be at the forefront of where the industry is. All of your students should be trained in the use of BIM. Like 2D CAD is like, that was sort of phased out a decade ago. Why, don't be training people on how to use 2D AutoCAD, because that's like obsolete technology. 3D modeling of building services, if that's part of the particular course that you're looking at, should be essential. Now, second thing, I think this is an emerging field. You want to be keeping abreast of the developments that are happening. Like every 2 years, like there's fairly significant changes that come about as the providers of BIM technology continue to innovate and develop new ways of collaborating. You want your students to be entering the workforce with the latest cutting edge technology, having already been exposed to it. And the only way you're going to be able to do that is if you're keeping abreast of what the software developers are producing. Providers like Autodesk and Revit and Tekla and that suite of tools, and there's a few others. But I think as the teachers in this particular space, your students would benefit if you were to be able to keep across the developments that they're coming out with, and the general direction that that software is heading, so that your students are like primed, not just to sort of enter the workforce, but sort of to jump in and take contractors who perhaps are still working in 2D CAD, and you could have some of your students could help revolutionize the way that businesses are operating. So
that's funny enough. That's one of the questions which came through with registration is, what would you say is the best way, if any? Their wording was to integrate, or potentially it could be introduce BIM where a business is predominantly using 2D CAD. So I think that's it's the new people coming through bringing the change.
Yeah. So you will have designer. Let's just say you've got designers that are working in 2D CAD. There's a whole heap of experience there. I would be investing in those particular staff, getting them, trained in the use of 3D BIM technology. They understand how the building goes together, or how the services needs to fit together, but it's not all that difficult. But even look, some people that transition might be challenging. They might not be too keen on it. Well, they still have a whole suite of experience that you could bring young people who hopefully have been trained in modern software, and then actually, they might not be needed to actually be drafting, but they could be, training in the actual design or the development of the mechanical electrical system, for example.
There was just, we are starting to get to the end of our questions, but one of the last ones was, what is the use of BIM in future digital twins? So maybe we can end on more of a futuristic approach.
Yeah, sure. I
So
can maybe
Christina,
try
did
and
you want
answer
to
that.
go?
Yeah, sure. So I think digital twins adds another buzzword into the space, and the digital twin concept is really broad and deep because it's something that's so the question is, how do you incorporate BIM with digital twins? So essentially, the BIM model plays a role. And you saw in my presentation, I talked about the JBot. So the JBot relies on the 3D model, which incorporates BIM. So JBot and also our total stations integrate BIM to be able to use sensor technology and locate and pinpoint places where you're going to drill the anchor holes, or you might need to mark out or set out certain areas, or the JBot's going to drill the automatic holes. So the digital twin space is really emerging in construction, and through our presentation, I think you've seen when it comes to the services, Australia construction is not starting to do that as the norm. It's not the norm that we use BIM models for services. So we're not there yet from that level. And I see digital twins as really a level up again. So I'm thinking from the context of construction and mainly from this topic, the services, it will keep evolving. I do know construction projects overseas. One of my colleagues mentioned it. There was the Sochi Olympic Park where they used sensors on the structural steel beams. And then this talks back to the model real time, and you'll be able to assess, is there any deformation, is it out of alignment, etc., etc. So that's really my perspectives on how digital twinning is evolving and how it relates to BIM. But I think this space is just going to continue to evolve. And we're still early in adopting it in the Australian market for just designing in 3D and trying to coordinate that on a job site. So I'm excited to see digital twin, but it might be a little way away.
Martin, did you want to add some final comments?
Well, look, I think that, there's very few buildings in Australia that have been instrumented from a structural perspective. And, how many of the high-rise buildings or the large hospital projects that we're putting up, cost 500, $1 billion, $1.5 billion, massive investments, and yet some small instruments that would enable us to actually monitor the performance, feed that information back into, say, a digital twin. It just isn't being provided. If you end up with an earthquake, a larger, a large damaging event, the ability to then go and carry out, effective structural assessments in a timely manner is really quite limited. You're working on visual inspections and crunching, or just going back to first. Well, I don't know, but the instrumentation that is available would enable a rapid assessment of a structure. And if you're talking about critical infrastructure, that could mean everything. So, look, I think that there is definitely a huge benefit in digital twins, and I think that industry will continue to go that way. It's probably in many ways there's so much more still to explore how you can gain from modeling. But modeling is the digital twin. Like, you've got to start with the digital space and create a digital replica of the real world thing. So certainly BIM modelling is the start of the process.
Awesome. Look, I just wanted really thank you both for joining us and for the discussion today. We really appreciate it. There's been a heap of thanks coming through on the chat box to you both.
Oh, nice.
I would also like to thank Engineers Australia's industry partner Hilti for their support with our webinar today, and really to help us improve and to plan future sessions for you, our audience. If you could please complete the short feedback form, which is linked in the description box below. Thank you again for joining us, and we hope to see you all at our next Thought Leaders event. Thank you.